We have Rob Bilott coming up, Jesse Miller. Rob Bilott is a famous attorney. Jesse Miller is with American University, John Scully, University of Virginia, and May Wu, who is with the Natural Resources Defense Council. Please sit down, make yourselves comfortable, everybody. Get a microphone. We appreciate 2 doctors, 2 PhD scientists. There's probably a joke that I could come up with on that, but I'm not sure what it is. So let's, we're late, so we're going to try to do this maybe in 45 minutes, although that's, we'll have to do a lot of sound bites to do that. But we will invite you to participate with questions and comments along the way. If you have something at any point, just raise your hand, try to get my attention, and we'll inject that into the mix. We want to talk about safe drinking water. This is something that, was it Jesse or May who said, safe drinking water might be one thing that can bring us all together. That's it. So maybe there's a bipartisan issue on the planet, and that would be you turn on the tap, you can be reasonably safe that what you're drinking is not going to hurt you. I think we can all agree on that one, right? Let's hope so. But, the devil is in the details, of course. And what the problem in this country is that chemicals used by industry for any purpose are innocent until proven guilty. And they get proven guilty often by cancer clusters. Or, who was it that said earlier each regulation is probably associated with a death or something to that effect? At the FAA, the term is the rules are written in blood. So these rules, which we're in an atmosphere now in Washington where they're going to be summarily dropped, all have good reasons behind them, and it's important that we think about them. And looking forward, as new chemicals come into use, we need to think about their consequences in new ways. You go to European countries, it's just the opposite. The chemicals are presumed to be guilty until they are proven safe to be used. That seems like a logical way to approach things, but that's not how we do it here. And that's how you end up with Rob Bilott getting a call some years ago from a dairy farmer in West Virginia who had some really, really odd cows that were very sick. And Rob, I know your story could take up much more than our 45 minutes, but I'd like to begin, as a TV news guy, I always like to begin with a story. If you could just tell us the story and how you, as a corporate lawyer who found yourself many times on the corporate side of the equation when it came to chemicals, found yourself with that dairy farmer and what that led you to. And I realize that's a huge open-end question, but maybe you have a short version of the story.
Sure. I appreciate it, and thanks for having me here. Yeah, I had been practicing law on the corporate side for a big law firm for about 9 years, representing chemical companies and other corporate defendants. And I got a call one day from a farmer out in West Virginia who had gotten my name through my grandmother because my mom's family had grown up in the area, and he was looking for a lawyer who could take on a case because it involved the landfill where his cows were drinking from a stream and it was getting runoff from a landfill. And he could see white, sudsy, foaming water coming out of the landfill. And he knew the landfill was owned by DuPont, which was one of the biggest employers in the entire community, the DuPont company. And he was having trouble getting anybody there locally to take on the company. So he came and met with us, and we looked at his photographs and his videotape of the cattle standing in the suds foaming water. And we thought this was something we could do that really help this family. Seemed like it was a fairly straightforward situation. You see chemicals coming out of the DuPont landfill, and it's in the foam. And to make a very long story, a little shorter, what ended up happening was we discovered that what was really going on here was this was a landfill where they were using to dispose of a chemical used in making Teflon. And it was one of these chemicals that had come out onto the market 50 years earlier, way before there was a US EPA, way before there were federal laws and regulations about these kind of chemicals. And this stuff was in the landfill. It was unregulated, not listed. And we had to fight to get documents about this chemical because it wasn't regulated, wasn't listed. And what we finally ended up seeing when we got all these documents was not only was this chemical in this landfill, but it had been known by the company internally to be a carcinogen, dating way back into the 80s. And even though it was unregulated, because it was unregulated, it was being emitted into the air, it was being emitted into the Ohio River, put in unlined landfills. We talked a little bit about that earlier today, all over the community. And what was happening was it was getting into the drinking water. And there were documents showing that not only was this chemical possibly impacting the cattle in this farmer's field, but it was in the drinking water of thousands of people in the community. And it had been in the drinking water for decades, but nobody had been told. And so we started a process at that point, this is back in the year 2000, 2001, notifying the US EPA, the state agencies, and that sort of began our education on how that process works and how difficult it is. This is one we heard earlier today, 80,000 chemicals that are out there. This is one that had come out before a lot of these regulations existed, and even though we had all this data internally about the chemical, we ended up doing big studies later on through litigation to get the public and to get the community the information that this actually is in your water and here's what it can do to you was a staggering process that took many, many years. And only just now are people understanding what this chemical can do, the types of cancers it can form.
So let's talk about it. It's perfluorinated, right?
Correct.
PFOAs. And this is, it's a surfactant, is that the correct term?
Yes.
It's a good word, by the way. That's a good word to impress your teachers. Surfactant. But it's used, I believe, some versions of it is used in Teflon, it's used in a fire retardant, it's used for a lot of things along those lines. Give us an idea of what this chemical's intended use is.
The chemical was actually invented by 3M back in the late 1940s, and it was sold to DuPont and others that used it to make other materials like Teflon. It was what they call a surfactant, something to help things kind of stay separated during the manufacturing process. And what would happen is this chemical was used in these manufacturing processes, and some of it would get into and stay in the final product. A lot of it gets emitted out into the atmosphere, and it's in all kinds of consumer products, or at least it was until very recently. Fast food wrappers, stain-resistant carpeting, stain-resistant clothing, frying pans, cable, electronic wiring. And the concerning thing about it is when this stuff gets out into the environment, it persists. It'll stay in the environment. It's totally non-naturally occurring man-made chemical. Does not exist in nature. When it gets out into the environment, because of the chemical bonds with these perfluorinated chemicals, it'll stay for millions of years in the environment. And it gets in human blood and will stay in humans for decades, even if you stopped your exposure. And the concerning thing is that meant the tiniest little bit in your drinking water. Some carcinogens, for example, you drink in, your body gets rid of pretty quickly. But because this stuff will stay in your body, it also builds up over time. So the tiniest little bit in your drinking water, year after year after year, builds up to higher and higher levels. And that was the really disturbing thing about this class of chemicals.
So PFOAs, there's some fairly good science on its link to cancer at this point, or is there a smoking gun link? That's difficult, of course, to connect those dots.
Yes. In fact, the one that we dealt with primarily was PFOA, which is also called C8 over the years. But what we saw when we got into the internal documents was there had been traditional animal studies to look for cancer effects, confirming that it caused cancer in animals as early as 1988. And then, of course, the workers, human studies were done. But and we talked, I think some of the speakers earlier today talked about statistically significant sample sizes and disease clusters. What was being done was being confirmed as an animal carcinogen. Then the companies were looking at their workers and saying, well, we're not seeing cancer in the workers, therefore it must be safe. Problem was, these were mostly adult, healthy males, not the elderly or young people that were being followed. But so when we had to go through years of litigation, at the end of the day in the litigation, we set up an independent panel to finally study the community, people drinking this chemical in their water, with independent scientists to study a big enough population so that you could actually find elevated, statistically significant rates of fairly rare cancers. And through that independent study of 70,000 people in that community, it confirmed to be causing testicular cancer and kidney cancer and 4 other diseases.
So, couple of factual points. You say the industry has walked away from use of PFOA. Is that right? And is that a voluntary thing, or how did that happen? Or was that you that
Well,
did that?
in around 2001, 2002, when we started notifying the agency, we saw this information and documents that the companies had that showing it's in the drinking water, it appears to be a carcinogen, has all these other health problems. People are drinking it and don't seem to know about it. What we also saw was it didn't look like the federal or state agencies knew anything about it either. So we notified the agencies around 2001, and over the next couple of years, as the agency started to figure out, wow, we need to look at this chemical, they announced in 2003, US EPA, we might actually look into banning this under the Toxic Substances Control Act. I know some of our speakers talked about that earlier today. And that's a very long process under the original rule. And as soon as that possibly regulating it under the law came out, the industry groups got together and agreed to voluntarily phase out any use or manufacture of the chemical in the United States. That was announced in 2005, but they were given 10 years to phase it out. And now new replacement chemicals are on the market, which there are scientists now saying, we know about as little about these new replacements as we did the originals, and are we just starting this process all over
So
again?
it could be a repeat. Give me an idea of, do we have any idea how many people might have been or will be affected by these PFOAs one way or another with some sort of health, whether it's cancer or something else?
Well, the chemical, because of its persistence, when this stuff is released out into the environment, it gets up into the air, it can travel the entire globe, and it's now being found in polar bears, in wildlife on every part of the globe. It's in human blood all over the planet. So you're talking about a massive contamination, worldwide contamination with these chemicals. And in the community we dealt with in West Virginia, in Ohio, along the Ohio River, outside a DuPont plant there that was discharging it in that area, we had about 70,000 people we knew had been drinking it, and we studied that group. And we have hundreds or thousands of people that have these either these cancers or these other diseases linked to the chemical now.
So you've got a career ahead of you litigating these cases, it sounds like, huh?
I think so. Yeah, we actually have about 3,500 of those people have cases already pending against the company.
So May, Natural Resources Defense Council, your logo is the polar bear, and your little polar bear has
It's actually Spirit Bear.
Is that a Spirit Bear? Okay. Still probably has PFOA in it. But so to what extent is this emblematic of a pattern and the way chemicals are introduced, used, people get sick, and this cycle, as he just alluded to, seems to continue. Is this typical in some respects?
Yeah, it is. And I think especially the drinking water contamination problem, it's something that, a lot of people, I think like our drinking water infrastructure and everything is a little bit of out of sight, out of mind. And so unless suddenly your water main breaks outside your house or your water gets shut off, you don't really think about where your water comes from, all the pipes that kind of lead to your house and the treatment plant that's needed to treat the water, and then where that water came from in the first place. And it's most of the people in this country drink water that comes from surface water, so from rivers, lakes, and streams. And these are the ones that we really have to think about how we protect them, because, when you're dumping, discharging from factories or whatever into these lakes, that is downstream. Some other community is taking that water and trying to turn it into drinking water. And the problem is that the EPA only regulates, there's only about 90 contaminants, chemicals that are regulated by EPA in drinking water right now. There are thousands more that are out there that could be, that they think are potentially in our drinking water right now. And because of a lot of different problems, EPA has a very hard time adding new contaminants to the list. So when when Congress amended the Safe Drinking Water Act in 1996, they set up this whole process by which you could add new chemicals and new contaminants to regulate under the Drinking Water Act. So since 1996, EPA has not set a single new standard without an act of Congress. So it's been, I can't do the math that fast, 20 some years, and we haven't added a single new contaminant to the list of ones that we would regulate under drinking water, which is a big problem. And then add to that that Congress is currently considering a Regulatory Accountability Act right now, which would put even more burdens and hoops and things in place to make it nearly impossible to set any new regulations under any statute here. So it's a big cycle and a lot of different points that need to be covered that are going to get missed.
So, as I understand, there's this containment candidate list, right? Every 5 years, they come up with a list of potential suspects. How big a list is that, and when was the last list released?
So they're required to come up with a candidate contaminant list, CCL, every 5 years. The current one has, I wrote it on my sheet and I forgot now.
Right.
It's like 90 some, I think.
So 90 possibles.
90 possibles.
That could be in our drinking water.
Right.
That we really haven't even assessed.
Right, and the PFOAs are on that list. No, I think they're on the they were on the UCMR. But yeah, so there are 90 some chemicals and microbials that are probably in our drinking water that are probably causing adverse health effects that EPA needs to look at and decide whether or not to set standards for.
How concerned should we be kind of nationally about drinking water given all of that?
A lot. It's a big problem. There's big, huge question marks there, and that's something that we just need to, put a lot more resources into to figure out what's out there and how we can treat it. But also, like, how talk about prevention. How do we keep it from getting into our drinking water in the first place?
And a lot of this, it has a lot to do with what you test for in the first place. I mean, in some respects, we really don't even know what's in the water, do we?
Right. There's a lot of some of the big hurdles are that we just don't have the analytical methods to even detect some of the things that we think are ending up in the water. I know pharmaceuticals is another area that's a big question mark that we know because we have this toilet to tap system, which is, we flush it down the toilet or flush it down the sink and it.
We just had lunch, babe.
Yeah, sorry. Stop eating
Enough
now.
Enough of that. Yeah.
So we know, people are flushing their, unused
Yeah.
and expired pharmaceuticals down the drain, whatever, and they're showing up in our drinking water downstream. But there are so many, medicines and drugs out there. Like we don't have tests for all of them in drinking water. So, yeah, it's a big unknown.
I mean, is this in the realm of impractical, or is it just something that if there was enough teeth and money provided to the EPA, we could solve this?
Oh gosh.
And that is a purely hypothetical question,
Yeah,
given
I
our
mean,
environment. But I'm just curious.
Yeah, it's probably again, there's probably like 6,000 contaminants that they think might be something in the universe of things that might be contaminating our drinking water. So that's a lot to come up with. A lot of money and a lot of effort could be done to address it, but that's why, again, prevention is a much easier way to deal with it, let's just not get it into our sources of drinking water in the first place.
So in other words, assess the chemical before the industry starts
Absolutely.
using it.
Absolutely.
And is that practical? Because you want to build a better pot or pan, and you're in a hurry to do that. How do you prove it's safe to use PFOA? I mean, it's a tough burden of proof, isn't it?
It is, but we do it for other things. So, for example, for pesticides, which are designed to kill things, Congress had decided that that's not something that we want to put out into the market before they're tested. So for pesticides, there's this very long process by which companies that want to put out a pesticide have to go through a very long list of tests, aquatic toxicity and animal studies and all sorts of things to show that this pesticide doesn't have certain unreasonable adverse effects. So you could do a similar thing with all these other chemicals before they're put out into the market.
So Jesse, let's talk about some of the emerging threats that are out there. What chemical, with thousands of chemicals to look at, how do you even begin the process of identifying where the trouble might be?
So I think that, I'm coming at this from an environmental exposure perspective of cancer prevention. And so I think that thinking about, like May said, thinking about prevention from the beginning. And you can really think about the chemicals that you could be exposed to in two categories, maybe those that are regulated and those that are not regulated, like May was saying. And so it's those that are not regulated that are the big question mark. The big ones that are out there right now, some of the ones that are a little bit, the non-regulated ones include, chromium-6 is a big one.
So wait, now just so people are aware, that
Sure.
do you know the film Aaron Brockovich, you youngsters? You ever see that? Okay, well that's chromium-6, and that if you watch that movie, you have the impression that she single-handedly solved that problem, but it persists in California and elsewhere. Go ahead.
Yeah, so, and it has actually been found in drinking water all across the U.S.
And it's a
So
pretty bad actor. I mean, we
it
know
is.
that, right?
It's a known carcinogen, yes. And so there are actually, and when we say known carcinogens, there are very few that the government labels as known carcinogens, and chromium-6 is one. So it is, and so to have a known carcinogen that is present in drinking water across the U.S. is a big problem. And how does it get there? Well, it's not naturally occurring. It's very rare to be naturally occurring. So most of it is coming from industrial processes, textile manufacturing, stainless steel manufacturing, metal plating. And it's also been found a lot in coal ash as well. So in one of the byproducts of the coal industry also.
So why is it still there? If we know, I mean, the bar is set very high to prove something to be carcinogenic. I mean, that really takes a lot. And the fact that it still persists, what list is it on?
Well, I mean, you ask why it's still there. It's persistent. It sticks around for a long time. And it is not regulated at the same level as other chemicals. And so even though that's part of the reason that it's still there is that it's not regulated, not federally at least. And so, however, California, New Hampshire, I think, and New Jersey maybe have regulations for it. So there are.
So just to be
What
clear,
are-
this is a known carcinogen, a celebrated story. Hollywood made a movie out of it. And there is still, to this day, there hasn't been a federal assessment of this. And when you get under the hood on this and you look at it, the review panels that the EPA sets up to look at chemicals like this are stacked with industry cronies with all kinds of conflicts of interest, with links right back to the companies that produce the chemicals and the industry that makes the chrome plating, or et cetera, et cetera. And you go to these hearings where they're assessing these chemicals, and it's stacked with industry people who are really putting their thumb on the scale. And I know you may or may not want to agree with me on that, but I just wanted to get that out there, that this process is not only slowed down and hampered by a lack of funding for the EPA, but it's also been corrupted by industry.
I think to differentiate between the science and then what happens after and how the science is used is a big,
All right,
is a
fair
big
enough.
issue. Because there is scientific evidence that shows that it has these carcinogenic effects, and then how that evidence gets used. And some states have taken it and have moved forward to do something with it, and other states are thinking about acting as well.
But taking a cue for the so-called tobacco playbook, there's a lot of junk science out there on that gets into the mix here. And so that's why you end up with a hexavalent chromium still on the list. So, John, let's talk about, some of this has to do with, we've been talking a lot about infrastructure here. And while, lead is not a carcinogen, I think somewhere between 6 and 10 million homes still have a lead service line between the water main and the tap. And that's where the rubber meets the road on cost, right? To dig up all those lawns and put in a new service line. That, I don't know how many billions that would cost, but I'm told that the overall water infrastructure bill, if we really wanted to fix it, is about $1 trillion, something like that. Give us an idea of whether we're spending anywhere close to that kind of money on improving our infrastructure for water delivery.
Well, first, thank you all for inviting me here, and I think to get that percentage of up from 17% of solving cancer problems, needs to cast a wider net. And so I'm glad you're engaging with the materials community, and we're here to help. We've spent a large part of our department's effort, but not only on what I call green materials. So we've looked at lead for a long time. We've actually looked at chromate more. And I could say a few things about chromate.
Please
if you don't
do,
mind.
yeah, go ahead.
So I don't know, I'm not the legal person, I'm the science person, but one thing I will say is the military has mandated replacement of chromate, and it's caused a lot of funding. It's brought about a lot of funding in materials science, and the cancer, the carcinogen information is there, but then there's the question of what do we replace it with? It's used as a corrosion inhibitor. And as I was telling Miles on the phone, so, we should not sacrifice public health at all, but it's used to keep airplane wings from cracking, for instance. So you've got, unlike the tobacco issue, which is a bad habit and no positive use, we've got chromium used. It has a use, and there is some risk associated with it taking it away, and there isn't a drop-in replacement, but it's got to be replaced because of this carcinogenic issue. And it's a real issue because airplanes, for instance, appliances that you may buy, commercial aircraft, military aircraft, they have hundreds of pounds of chromate. And even if it's mandated to be removed, how do we get it off of there without contaminating, as May said, the water supply? So there's a whole issue on what respirators, equipment people will need, how will you dispose of it. And so there is hope. There are some replacements for about 15 or 20 years. There have been some alternative candidates, but industry doesn't get incentivized to do that until there's regulation and until there's other driving forces. So you had mentioned in these panels being loaded with industry participants, and I don't disagree with that. But what you see that certain states that want to sell their equipment, for instance, in Europe, they cannot sell anything with chromates in Europe. So now the Boeings or the whatnots, the Lockheed Martins are incentivized for business reasons, not as laudable as we'd like, to not do this. California is a state, so this is a state level. They want to follow what Europe is doing on a lot of heavy metals, right? So that's my comment about the
So to
hexavalent
the extent
chromium.
that industry has to operate in a global environment, the European regulations actually end up helping us.
The European regulations end up helping our industries that seek to sell things around the world.
So
And they may not do it, the Ambrokovich, because it's the right thing to do, but they'd end up doing it in the long run. And they're for about 20 years, the materials community, driven by the possibility of regulation, the possibility of mandates, have studied alternatives to chromate. And I'm not trying to, there is a real issue if you look at some airplanes, especially these planes that fight fires. They tend to be older airplanes. You see these movies where they drop the chemical in the fire and the wing falls off, and that's a real issue. And so it's a little bit different than the tobacco issue where there's maybe no good reason, but there's some habitual reasons. You've got sort of trade-offs, what we call in the materials community trade-offs. I'm not defending chromate. There are, if you put enough science on it, like the issue of detection, I think these things are solvable. How much money is the question.
let me ask you this question, whether it's you or anybody else in the panel. Is it incumbent upon an organization like the EPA to, at the bottom of the ledger, consider not just what the impact might be to ingest it, but also what would be the impact if it was not used on that airplane wing, and figure out in an actuarial way where are the lives?
Right.
Do you
So
have
I'm
to
just
do
making
that?
a small point.
Yeah.
That's right. There's the risk assessment
Yeah.
with multiple risks, and there is some culture too. In the military, there's a big, in any kind of design process, there's a big penalty for for doing something wrong, finding a replacement that doesn't work, and there's a catastrophe. And there's not as much incentive, and there should be, for replacing it to deal with these long-term health
Well,
effects.
and if you're designing an airplane wing, you're not thinking necessarily about what you're drinking
Right.
when you open on.
But there's
your
also, I'm
tap,
going to
right?
go back to
Yeah.
lead a little bit, and I should let other people, but chime in. But the lead issue, one of the things we were talking about, like with asbestos, is documentation. It's not documented. So in Michigan, Flint, Michigan, which we've spent a little bit of time working on, they had 45,000 index cards in a municipal building trying to say where the lead pipe was. They don't even know where it is. They were accusing people, residents in Flint, of having high lead levels at the tap because they had lead, they had done something wrong in their home, when the municipality didn't even know where the lead pipe was in the water system. And the other thing is, I just want to throw in one point, is it's a $1 trillion problem. There's probably over 2,000 municipalities or waterworks, and affecting 10 million Americans at least. and poor documentation of where the lead is used.
Rob, I think a lot of Americans would be surprised to hear that just the very fact that chemicals are introduced without really any study being considered for their impact on human health. Why is it that way here? And what did when and where? How did the Europeans get better at this? Why?
Well, you know, the American system really started in 1976, the Toxic Substances Control Act, and was really focused more on the new chemicals coming out, and really didn't focus on. And one of the, you know, one of the ones I was working on most was one of these already existing chemicals. And in the European situation, and I'm overgeneralizing here, but as you say, you know, the concept was to come up with legislation that would require all of these things to be analyzed, tested, reviewed before they go on the market. And you know, that's what I think was the intent of the recent revisions to the U.S. system, was to try to make that more in line with that concept and to have more testing done, more study done up front before these things come on the market. And obviously that law just got changed. I think it remains to be seen how effective that is, and whether that does really create a different approach toward these kinds of issues in the U.S.
May, what do you think? Is there a change? Will the TSCA change it?
Well, yeah, it's a big change, and the devil's going to be in the details, because it's up to this EPA to start looking at. They have their first set of like 10 high-risk chemicals that they're going to be looking at, and we'll see how this administration's environmental agency is going to handle that assessment. And, you know, like I said, there's all these, you know, we talked about the Congressional Review Act, there's the Regulatory Accountability Act, there's a lot of things that are being put in place by this administration to make it a political decision, not a scientific decision, on how these things play out.
It's a little bit troubling. Let's talk about the administration in a moment, but the one thing does occur to me. If you're talking about a drug, you go to the FDA, and we all sort of familiar with that whole process. Anything you ingest as a drug, you would have FDA approval. In a sense, should drinking water be under the purview of the FDA with that kind of thinking, or is that it's kind of a gray area, isn't it, in some respects?
It's an interesting idea, but you know, it kind of, you know, we still have to remember that drinking water is still a whole system, right? So we
Right,
have
yeah.
the environmental impacts that are causing this downstream stuff. So I don't know that FDA is equipped to look at the environmental impacts from.
Well, yeah, I'm
things
not
that would
saying
cause
they
the
necessarily
drinking
have
water.
the
Yeah.
horsepower to do this,
Yeah.
but that approach might be a different way of looking
That's
at it. So anybody else want to talk about Europe versus the U.S.? Yeah, go ahead, Jesse.
So the REACH legislation in the EU takes more. I just wanted to mention the precautionary approach, because
Right, yes.
it's a very different approach to regulations when you have foresight and you're doing something that's more proactive and precautionary versus a reactionary approach. And so it's a very different regulatory system, and that's all I'll say. But it's hard to compare the two because it's a different approach.
If you wanted to create a precautionary approach here, what would that take?
It would take knowledge and scientific evidence to know what's going on with the chemicals before they go on the market. Whether
Right.
you're talking about like pesticides, like May mentioned, which we do know a lot about them before they go on the market, or any sort of chemicals that are industrial chemicals or household use chemicals. And then it's interesting to think about pharmaceuticals and personal care products, but again, they're regulated by the FDA until they end up in the drinking water, and then we have to deal with them with the EPA. So knowing more scientific evidence, but where is that responsibility? Where does that fall? Does that fall on the American public and taxpayers to pay for that through the EPA and the FDA? Or does that fall on the proponents, the people that are wanting to use these chemicals in the first place?
Is it reasonable to expect that science can give timely enough answers so as not to provide too high a regulatory burden on industry that wants to use these chemicals?
I think it probably should fall on industry if they want to use the chemicals, because they're the ones that benefit from it directly. They're not often the ones that deal with the externalities and the other costs that come to the public after the fact.
John?
I just want to say one thing, that having participated in rating standards, which is something that's eye-opening is that unlike the thinking that might go on in Washington today, standards are not usually developed by zealots that overreach, and they could be burdensome, but they don't. That's not the way they're done. They're done, as you said, by science. The trickle down. I could put 5 material scientists on a problem and solve it, and someone could have a cardiac problem, and we could put 5 surgeons on it, but that's not the point. The point is that we can distill that science down to a level that a plumber, a municipal water worker could use. And most standards are, as I mentioned to you on the phone, are gems. The lead and copper rule, it was gamed in Flint, Michigan. And so, while it's pretty ominous to talk about these chemicals that aren't regulated, and that's a very good point. The ones that are regulated, some of the standards are very good. The Safe Drinking Water Act you can't. The bigger problem is these legacy materials not knowing what was done 100 years ago. But the science and the development of most standards, I would say every standard I've ever seen is very rational. It's not an irrational zealot type approach.
So give me a few more words on how the lead and copper rule was gamed in Flint. That's interesting.
Right. Well, the lead and copper rule, briefly, everyone, says that there's a limit for copper release that's pretty high and a limit for lead that's really low. And the more science that's done on the medical side, the lower it becomes, like 0. But right now it's 15 part per billion of lead, and there's a 90% rule. And for those of you that are students, that just means if you've got 100 samples and 10 of them are above 15 part per billion, then you declare that water unsafe. And I don't know if you read,
there's no safe level of lead
right.
at all,
They,
right?
they declare that safe. That's
Yeah. Right.
a very, very important distinction. Right. There is a 0 level probably, so that's the way it's currently used now.
I don't think Mr. Pruitt knew the answer to that
Right,
question.
and so the punchline is that's right. So the punchline
So if he's
is
listening, if
you
run
have
into
10,
him, why you-
I hope he watches the YouTube, right?
Yeah.
So if you and how do you game that? So what I'm trying to say is just to review again. If you have 10 samples that come in above 15 part per billion, the water's deemed not drinkable. But the lead and copper rule was they went into the houses, and how they gamed it was they went in, they didn't do those statistics. They also ran the faucet and they told people to run the faucet, which might have some basis, but that's not what the rule says. And so there are ways that you game standards so that you pass the standard.
and people get hurt.
And then people get hurt. Yes, sir.
So any more words it may? Go
Well,
ahead.
I just wanted to highlight again, Flint had no violations of the lead and copper rule. That's how you know that there's a problem with the rule. And, the way he talked about, there's definitely different ways that you can take the samples, how you choose where to take the samples. So maybe that there are homes that aren't necessarily serviced by lead service lines. Do you go there? And there's a whole list of different ways that the samples could be taken that would miss a problem.
And the other thing that I agree totally, and the other thing that they did there, along those lines, is that they are given 6 months to comply. And that's kind of crazy if you think about it. One of the tests that I've done in my laboratory this summer, unfunded, I just had for you students, I had my graduate students and undergraduate and high school students just opt in to do this. This wasn't their thesis research. We didn't have time to write a proposal. The people in Flint, Michigan deserve some help. We're very fortunate at the University of Virginia, so we were doing tests at 5 o'clock in the morning or 2 a.m., and we did some tests on this. So it takes a long time for some of these inhibitors to work, or for you to build up films where you don't release the lead, and they're given 6 months to comply. But they were so far above the level that there was no hope of ever complying. And then meanwhile, people are ingesting lead. And so that's another way. There are multiple ways in which the system was gamed.
What's the motive for gaming the system? Is it just nobody wants to bother?
Yeah, to avoid the violation. And it's not just the lead and copper rule. There's a lot of, like I said, EPA regulates about 90 different contaminants, and there are different ways to game the system for all of them. So you can get, the way it's set up, you can get monitoring and reporting violations, or you can get a violation of the health-based standard. So some systems for some of the rules may decide, let's just not sample for it altogether. I'll get a monitoring violation, so I don't get the health-based violation, which requires things to be done.
But kind of lost in that is that people are
People are
harmed.
getting sick. Yeah.
I mean, let's not forget that. All right. So what are we going to do about this soon-to-be confirmed EPA director? Rob, what are your thoughts on if drinking water brings us all together? Will this be the one area where the EPA will do its job?
Well, I've heard other speakers
Put the mic up. Yeah.
Sorry.
Yeah.
Other speakers have already said this today. I don't think clean drinking water is a Republican or Democratic issue. I mean, I think everybody would. How can you get up and say you're not for clean drinking water, or you want to continue having carcinogens in your water? So I think it should be a fairly straightforward thing to do. And, I think what's going to be an interesting dynamic, though, and I think we're already seeing this to some degree with the chemical I've been dealing with PFOA, which is at what level? Is it going to be something dealt with as a national drinking water issue? And I know you talked a little earlier about the way the current system works. In order for something to be regulated on a federal level, you first have to show that it's a national problem. And so EPA requires people to go out and start sampling for these chemicals. And there's ways to, if you talk about gaming the system, there's ways to change those results. If you have your detection limits a little too high, then you only find it in certain places, and you find it in a small percentage, and then your issue becomes a local issue that could be delegated to states. And with PFOA, for example, we're seeing states step in and take the initiative. New Hampshire, Vermont, the state of New York, where these chemicals are now showing up, and they're showing up all over the country. You got firefighting foam in all these military sites across the country. You have states that are stepping in and saying, we can do this and we can do it quicker. The concern is states like, for example, that I dealt with, West Virginia, that claim we don't have the resources, we don't have the toxicologists, we'll wait for EPA. So it'll be, I think, very interesting to see how that dynamic plays out, particularly in states that lack the resources to do that kind of work.
My understanding, there are certain states right now that take primacy over the EPA when it comes to drinking water. I think Wyoming is sticking in my head for was one of them. And, it's interesting because most pollution issues, if you start with climate change, that's global. Air pollution is at least national. Drinking water is one that could be solved in the local state level. And so maybe this is something that state legislatures can push for. Are we seeing any other, are you seeing some real action on that front? Anybody? Go ahead, Jesse.
I think that while that's possible, and we're definitely seeing that with some states stepping forward to address some of the big ones that are out there right now. We run into issues, though. It's kind of like with air pollutants also, same thing, where we have chemicals that cross state lines. So then what? It's not just limited to one state or the other. Water moves. Air moves. So even if it is produced in one state, it might actually be causing problems in another state.
So, May, what are your thoughts on the Trump administration EPA as it's shaping up right now?
Yeah, let's go to the states. Let's get the states. I mean, as one of the examples of just how bad the system was already up before today is, there's one chemical perchlorate, which is a component of rocket fuel, that in 1998 was put on this candidate contaminant list. In 2011, the Obama administration said, this is a problem, we need to set a standard for perchlorate in drinking water because of the impacts that it has on fetuses especially. Under the statute, they had 3.5 years to finalize a standard. In 2016, 5 years later, NRDC had to bring a lawsuit to force them to start because they hadn't even proposed a standard yet. And our lawsuit, the settlement of that one says that they have to propose one by 2019. So we are 20 years from when, one chemical, 20 years that it took for us to get to a point where hopefully, who knows if we'll get a standard. So, just the way it's set up right now, I just don't see, and with the way the administration's looks like it's going, I think that the states are really where we're going to be putting a lot more emphasis for at least the next few years.
Was there anything in Mr. Pruitt's testimony that gave you perhaps greater concern, or maybe some reason to believe there might be some shred of hope somewhere?
No.
All right.
No hope, sorry.
Yeah, no hope.
Yeah.
Rob, in Pruitt's testimony, his record, what do you see?
Yeah, I have to admit, I don't know that much about his background. All I can say is I hope that, particularly with the chemical issues we're dealing with here, unregulated chemicals that require public awareness and notification. At a minimum, that some process be in place that when these things are showing up in drinking water, whether it be through federal or state, that there's a way people learn about it. You've heard so many people today talk about education is the key to prevention. And knowing what's in your water is key. Regardless of what level of government's going to address it, getting the information out to people who are actually drinking it, that it's there at a minimum. We know it's there, and make the information available. And hopefully that'll happen at some level, whether it be federal, state, or otherwise.
Jesse, how worried are you?
I'm very worried, but my biggest issue is science. I think that the move away from actually looking at the science and the evidence to support different changes, whether it's for drinking water regulations or any of the other environmental issues and climate change, any of the environmental issues, that the move away from actually looking at science and turning more towards political reasons and political decisions, that's my biggest worry.
John, how about you?
I would agree with everyone on the panel. I would say that, again, that these proactive approaches are much better in the long run. If we took we're interested in public health, but if we took a strictly business point of view, these would be smarter ways to go. I mean, the cost of asbestos or handling the lead drinking water issue after the fact is enormous compared to the old saying, an ounce of prevention is worth a pound of cure. And I really think it's not wise, and to politicize it is unfortunate, but it's just not a wise, even business decision to make. And I think that maybe the states are going to have to take this on more. And you'd think people have a right to clean, safe water, and they do. These people in Flint, Michigan can't defend themselves, and that's why it's great that people jump in and help. Mark Edwards at Virginia Tech, for instance, who was a whistleblower along with Mona. Natasha. So I just think that, people will have to go down the state level or maybe even individual test kits. I mean, there are some innovations that I have hope for. That should people be responsible for their own water? No, but it still can be technically achieved, though.
Well, that segues to the last area. What can we be doing as individuals? Is that one of the things we should be thinking about?
Well, I go back to the science, and again, it's the question of who's going to fund the science, because if industry's not going to fund it, I totally agree. And if government's not going to fund it, I'm not sure. You could start foundations that fund stuff. I mean, I think that is probably a way that will have to be considered. That we have foundations that fund these things that are necessary, whether the government agrees or not, if they're going to politicize it. But I think there are some technological innovations. But I think the science, I agree totally. The science in this country is to help you make informed decisions, anyone, to make smart decisions, right? And that can trickle down to a standard that's not made by a zealot, but is made so that a practitioner can deal with the problem, and you don't have to call in 5 PhDs.
No alternative facts, right? Go with the facts. May
If you vet it through the open literature, I'm an editor of a journal, that's the process. See, people underestimate that scientific process, but when you vet it through journals with peer review in their prestigious journals, I mean, people say that's the ivory tower approach and that's the old establishment, but there's good to that process, that stuff gets vetted through the system, and junk science doesn't get out in these credible journals. So when these politicians talk about alternative facts, you look at the level of expertise of the journal, and it's not there for these alternative facts.
Well, a lot of
so
these,
if you want to look, you can evaluate quality of science quite readily.
There are journals, and then there are journals, and that's the problem, right? Some of these are just bought and paid for by industry. May, what are your thoughts on individual actions, things we should all be doing? These are young people. I often tell my kids that, you've heard of the greatest generation. Your dad is part of the worst generation. We've really screwed everything up, and now you have to fix it. So you guys have to fix all this for us because we made a mess. What should these kids do?
Well, I was going to say for homeowners, y'all may not be there yet, but there are, you can demand from your drinking water utility that they come and do tests, especially for lead, and a lot of them will do them for free. There are also test kits that are available. So I think that there's some, when you talk about awareness building, I think that educating yourself about where your water comes from and getting engaged with your water utility, because you are the customer, so they have to listen to you, and start asking them questions about what it is, what's the source of your water and what are they doing to protect the water, just really letting them hear, the utilities hear from you is a big deal, but also, again, the earlier speaker said it, getting involved in this process here, like on the Hill, and having and reaching out and saying that this is something you care about and everybody around you cares about, and that they need to do something about it is really important.
Rob, give them some inspiration.
Well, I think every one of you should realize, I mean, you can really make a difference yourself by just assuming. You can't sit back and assume somebody's looking at this. Let's take water, for example. Somebody's looking at our water, screening it all for us. When you turn that tap on, just assuming it's all fine. I mean, you have to really get engaged and work on these issues yourself and make sure. And the thing I think is still really lacking out here is ways to get information out to people. Ways to get information to communities. A lot of places, all you get is your annual drinking water report that tells you, and as we've heard today, there's only a small list of things that are required to be tested for, that they're required to tell you about. And there are all kinds of other things you could be asking for. You could be asking for information, finding ways to make that information available to the community. So that, again, people at least know what they're being exposed to. They have some opportunity to avoid the exposure. If you don't know you're being exposed to something, you can't avoid it.
Jesse?
Yeah, I'll second both what May and Rob and John said. I think that becoming informed is the most important thing. So whether that's your own drinking water or if you're interested in a specific topic, dig deeper and talk to experts and call people, call your congressman, call scientists, call people, become informed and speak up.
So I think the election of 3 months ago has taught us the lessons of apathy. So let's take some action, everybody here. Anybody have questions for the panel? Go ahead.
In terms of being informed, I'm a PhD student at the University of Virginia, looking at health disparities. How has racism contributed to these disparities that we're talking about?
Yeah, it does. Environmental.
Is it race or is it socioeconomic? I mean, or
well, I
both?
mean, I
Yeah.
think they're very
Yeah.
closely
Hard to pull those two
intertwined.
apart,
Yeah.
anyway.
One of the examples that I have is one of the cases that NRDC litigated was in Dixon County, Tennessee, where there was a landfill that was contaminating the drinking water with TCE, and they knew about it. The city and the county knew about it, and they informed the people who lived here, who happened to be white, and told them not to drink the water, but did not tell the folks who lived down here who happened to be black, and said their water was safe. That was, and we ended up, that case turned out very well, that the county had to put drinking water treatment for the people that they had they had ignored for so long. And I think Flint's another example. I mean, time and again, environmental justice is a huge issue, and it's not just drinking water. It's where factories are located, where hog farms and, these very polluting industries are located. They're always, oftentimes located in poor or communities of color. And it's, that's a huge area to look into and study more, because it is very prevalent.
Anybody else on that subject of race and economics?
No, I will add just factually that in Flint, Michigan, we can call it socioeconomic or racial and subject to interpretation, but the emergency management of the city of Flint, they decided not to put a phosphate inhibitor in there that would mitigate corrosion and limit lead release. And the Flint River water was very corrosive, but that was for another reason, because they were switching to Lake Huron water and didn't have the pipe finished. But anyway, back to the point, they viewed these people as not able to manage their city, and the orthophosphate inhibitor would have cost $100 a day. And again, I'll go back to the cost.
So to make that clear, the
$100 a
entire
day.
Flint crisis
Really
could have
cruel.
been averted
Yes,
for
sir.
$100 a day.
For $100 a
Citywide,
day.
not per individual. The
Right,
entire
$100
city.
a day. That's why I say that the prevention piece is really important. It's been mentioned several times today, and that's obviously the role that we play, but I think that we can all play. And there's an example of where it's literally penny wise and pound foolish.
Anybody else with questions? Yes. Good question. What can we do at home? What do you recommend? Filters?
Well, the one thing I'd say about the filters is that the filters can be susceptible to their lifetime, and you don't know in your home. So I'll just leave it there and let these experts speak. But So
Remember
it's
to
something
change-
that
in
can
other
be
words,
done,
remember
but
to
it's
change
like a
them,
Band-Aid.
right? Yeah, it's
Right.
very important.
Remembering to change
Yeah,
them exactly,
yeah.
or knowing when they don't work anymore.
Yes, the different filters work for different chemicals, and so that's something else you need to be knowledgeable about. And that probably starts with getting your water tested first to know what's in it, and then getting the filter that will remove those contaminants.
Yeah, for example, with PFOA, it was determined that you could filter it out with a really simple activated carbon filter. And in fact, some of the kinds that are sold over the counter and in your regular store you can go get and put on your home tap would work to filter out PFOA. It had to be changed quickly. And for example, we had a situation in New Jersey where it was contaminating the groundwater up there. Part of the way that was resolved was getting people filters, but also providing much more frequent change out of those filters and having the education about how quickly they had to be filtered out. But some of these contaminants, like the perfluorochemicals, can be removed with very simple technology once people know it's there and it needs to be dealt with.
And just to be a little more detailed, so if you go to the NSF International website, they certify water filters, and you can actually click on it and pick like the kinds of chemicals that you want to filter out, and then they'll pop up like a list of the filters that are certified to remove those specific chemicals. Because if you happen to live in a more agricultural area and you're more worried about, like, say, pesticide runoff versus if you live in a super old home and might have lead in your water, that might be a different kind of filter that you'd want to do. So that website should help.
Anybody else? Oh, we want to take a few more, or should we do?
Yeah, well, we have closing comments.
Yep.
We want to make sure we get a group picture of everybody.
All right. Can we do two quick ones, and then we'll call it? All right, go ahead.
So you said that the water contamination, like the unsafe water, can affect fetuses, and especially with this new administration and the vice president especially, who has put at the forefront the protection of these fetuses. How can they justify not putting, like, keeping this water safe, like at the front of all? Like, how can they say?
It's a really good question. Yeah. What you're telling me is there are double standards in Washington? Is that right? I might have to do a story on this. I don't know. This is. Go ahead. One more final question.
So, as you guys heard before, I'm a legislator in the state of New Hampshire, and I have 4 bills in play right now that have to all do with drinking water. And I just want to say, at the top of the Republican Party, my bills are supported with co-sponsors. So that's gotten wide Republican support on both sides of the fence, actually. As a result, we started overnight, basically, within 24 hours, we started a Facebook page called the New Hampshire Safe Water Alliance, which was an advocacy group we started. We had over 100 people in 24 hours. We now have 150 people after only a few weeks. And I was talking to one of the heads of the Republican Party yesterday, and they said, you need to bring me something I can approve because my constituents are driving me nuts. So I have to be able to approve something to help them, go back to them and say, we're going to have safe drinking water. So advocacy is really important. It starts at the grassroots level, and you can really make change. So, and my question is, can everybody on the panel give me your cell phone number?
All right. So I guess the moral is we can't take anything for granted. We can't take the environment for granted, the water that comes out of your tap. At this point, I don't even think we can take our republic for granted. So by all means, stay in the game, stay vigilant, especially over the next 4 years. Thank you very much for your time. Thank you, panelists.